Hello viewers, welcome to our YouTube channel Incredible Maths. In this video, we will solve some 4 problems asked in GATE 2022 Mathematics. So the first problem is the radius of convergence of the series summation n greater than or equal to 0, 3 power n plus 1 to z power 2n. So we will use a ratio test to find the radius of convergence of this series. So the formula is limit n tends to infinity modulus of an plus 1 by an. So the series will be convergent where an is the nth term and an plus 1 is the n plus 1th term. So the series will be convergent if this ratio is less than 1. So this is equal to limit n tends to infinity. So replace n by n plus 1, so we will get 3 power n plus 2 z power 2 times n plus 1 divided by an is an we can write as it is 3 power n plus 1 z power 2n. So this is equal to limit n tending to infinity. So 3 power n plus 1 into 3 z power 2 plus n 2 power n to z square divided by 3 power n plus 1 z power 2 2n. So these two will cancel. So the remaining thing we have is a limit n tends to infinity 3 into z square. So we have z square. So this will be convergent when this ratio is less than 1. Therefore 3 modulus of 3 z square is less than 1. So this implies z square is less than 3 and z is less than 1 by root 3. Therefore the answer is 1 by root 3. So next question. So number of zeros of the polynomial 2z power 7 minus 7z power 5 plus 2z cube minus z plus 1. So here we can use Roche's theorem to find number of zeros. Roche's theorem. Suppose if f of z and g of z are holomorphic, say C, then f of z and f of z plus g of z have same number of zeros inside C. So here we can take so the region is z belongs to C such that modulus of z less than 1. So inside or we can take. So now we will choose f of z. So this is based on trial and error. So we can take f of z to be minus 7 z power 5 and g of z equal to the rest of the things 2 z power 7 plus 2 z cube minus z plus 1. So we have one more condition, f of z and g are holomorphic inside and modulus of f of z is greater than or equal to modulus of g of z. So now we find modulus of f of z. So modulus of f of z is equal to 7 and modulus of g of z equal to, so this is less than or equal to 2 plus 2 plus 1 plus 1. So this is equal to 2 plus 2 4 5 6. So here 7 is greater than 6. So the condition is satisfied. So that is modulus of f of z is greater than or equal to modulus of g of z. So therefore the number of zeros of the polynomial inside this region is equal to number of zeros of f of z. So number of zeros of f of z is 5 because we have z power 5. So now number of zeros of f of z is equal to 5. So this 5 corresponds to this 5. So therefore, the answer is 5. So this is according to Rouget's theorem. Rouget's theorem is if f of z and g of z are harmonic inside some region R, and modulus of f of z is greater than or equal to modulus of g of z, then f of z and f of z plus g of z have same number of zeros inside R. So this is our f of z, and f of z plus g of z is a given polynomial. So next problem. The maximum value of f of x comma y equal to 49 minus x square minus y square on the line 3x plus 3y equal to 0. So here f is a function of two variables. So based on this given condition, so we can convert this function of two variables into a function of single variable. So from this we will find x. So x is equal to 10 minus 3y. So therefore, we will substitute f of x comma, for y we will substitute, for x we will substitute 10 minus 3y, and y will be as it is. So we will get 49 minus, so x is 10 minus 3y square minus y square. So it will be a function of single variable f of y equal to 49 minus 10 minus 3y square minus y square. So to find the maximum value of f, so we can use first derivative test for single variable. So that is, so this is f of y. So now we will equate f dash of y to be 0. So this implies 0 minus 2 times 10 minus 3y times minus 3 minus 2y equal to 0. So we can remove this 2 and negative also. So minus 2. So we will get minus 30 plus 9y. So here we have so minus 2 is cancelled, so plus y equal to 0. So therefore from this we can find y is equal to 3. So minus 30 plus 10y equal to 0. So y is equal to 3. So now we will classify whether the point 3 is a maximum point or a minimum point. So before that we will find x corresponding x. So this implies x is equal to 10 minus 3 times 3. So this is equal to 10 minus 9. So 10 minus 9 is 1. So we will find f dash of y. So f dash of y is equal to, so f dash of double dash of y. So f dash of y is this one. So this is our f dash of y. So we differentiate once again. So we will get so this is minus 2 minus 3 6 times, so 0 minus 3 and so minus 2. So this is equal to minus 18 minus 2 minus 20. So this is less than 0, implies, so this function f of y has maximum at y is equal to 2. So we need to find the maximum value. So the maximum value is by f of y is equal to 3. So f of x equal to 1 and y is equal to 3. So this is equal to 49 minus 1 minus 9. So the answer is 39. 49 minus 10, so therefore the answer is 39. So the answer is 39. So we will solve one more problem. Given the function f of x comma y equal to x square plus xy plus y square plus 1 by x plus 1 by y, x not equal to 0, y not equal to 0, attains its local minimum value at the point a comma b, then the value of a cube plus b cube. Okay, so here we will use a shortcut trick for this function f of x comma y. So clearly we can see that f of x comma y equal to f of y comma x. So therefore f is a symmetrical function, that is f is a symmetric function. So if f is a symmetric function, then so the critical points will be x is equal to y. So x is equal to y is the one of the critical point. So now, so put x is equal to y. So we will have function of two variables tends to a function of single variable. F of x comma y equal to x square plus x square, x is equal to y. So x into x, x square, y equal to x, x square plus 1 by x plus 1 by x. So this is, so 1, 2, 3, 3x square plus 2 by x. So now we will, as usual, similar to the previous problem, so we will find the first derivative and equal to 0. So this implies 6x minus 2 by x square equal to 0. So therefore, so we have 6x cube minus 2 equal to 0. So that is 6x cube equal to 2. So therefore x cube equal to 1 by 3. So x is equal to 1 by x cube equal to 1 by 3, and so this implies, so what about y cube? So y cube is also 1 by 3 because x is equal to y. So we need to find, so x comma y is a critical point, so therefore we need to find x cube plus y cube. So x cube plus y cube equal to 1 by 3 plus 1 by 3, so this equal to 2 by 3. So therefore the value of a cube plus b cube is, that is x cube plus y cube is 2 by 3. 2 by 3. So this is nothing but 0.67. Okay. So the remaining things we will see in the next video. So if you like the content of this video, so kindly like and share with your friends. Also subscribe our channel for more videos.